Bismillahirrahmanirrahim. Today we will start Poisson probability distribution. Before this we have done binomial probability distribution. So this is the second discrete probability distribution, Poisson probability distribution. And what is the Poisson probability distribution and when we use the Poisson distribution? This is the most important thing. So these are the characteristics and properties of the Poisson probability distributions. So a Poisson process produces a discrete number of occurrences, same as the binomial. In Poisson distribution, the outcomes or occurrence is discrete in a continuous interval, within a continuous interval. Discrete observation occur in a continuous interval. For example, the interval may be any continuously measure of time. You know that the time is a continuous variable. Distance is a continuous variable. Area is a continuous variable. So if any discrete observations occur in a continuous interval, is called Poisson process. For example, the random variable of a Poisson process is the number of occurrence of x within the interval. For example, the number of telephone calls per hour interval. Number of telephone calls is a discrete observation. You know that the telephone call may be 1, 2, 3, 5 and so on. Per hour interval means time is always continuous. So this is the continuous interval. Number of accidents at a particular intersection in 1 year. Accident is a discrete outcomes. Time in year or month or day in hour is a continuous. Number of typing mistakes. Typing mistake may be 2, 3, 4, 5 and so on. Per page, the area of the page is a continuous. So you can say that if the number of discrete observations occur in a continuous interval, then we apply the Poisson probability distribution. Technically or statistically we can describe this process as follows. These are the characteristics of the Poisson distribution. The number of occurrences in an interval is the independent of the number of occurrences is another interval. Intervals are independent. Suppose if you collect the number of accident per hour, in first hour maybe 0 accident, second hour maybe 20 accidents. So both are independent. The number of occurrence in an interval is the independent of the number of occurrences is another interval. In another interval, the expected number of occurrences in an interval is proportional to the size of the interval. If size of the interval is large, the number of expected occurrences or average values will be large. If the size of the interval is small, average value or number of occurrence will be small. For example, suppose if you collect the accident per month and then collect the number of accident per day. So per day is a small interval, per month is a large interval. So in per day accident will be small, average will be small, per month will be large. So you can say the expected number, you have done mathematical expectation, average value, expected number of occurrence in an interval is proportional to the size of interval. A very small interval may be identified. You can divide the area in or time in very small interval. You can collect the accident per hour, per minute, so that no more than one occurrence is possible in any interval of the size. Maybe 0 interval, 0 observations in a small interval. Okay. And about the Poisson probability function or formula, the probability distribution of the Poisson random variable x, you know that in probability distribution we use the word random variable instead of variable. Random variable x representing the number of outcome occurring in a given time interval or region. This is a formula of the Poisson property distribution, you know that in general we use the notation f of x for any function. For probability function we use the probability x is equal to x, and this p represents the Poisson distribution. X is the variable, mu is the mean. In binomial distribution we require two parameters n and p with x, but here only one value of the mean required for formula. And the range of the observation from 0 to infinity in binomial distribution, the range is from 0 to 20. If n is more than 20, we use another distribution like Poisson distribution and normal distribution after transformation of the value. So the formula of the Poisson distribution, summation x0 to infinity e raised to the power minus mu. E is the constant term given in your calculator. The value of e is 2.718. Power minus mu, and mu raised to the power x divided by x factorial. This is the value of x is the value of the given condition, where mu is the average number of outcome occurring in the given time interval, and e is the constant given in calculator. Okay, this is the detail about the Poisson property function. Next heading, Poisson properties of the Poisson distribution. These are the some properties, important properties of the Poisson distribution. First, it is univariate and discrete type of distribution, same as the binomial distribution. It has one parameter, that is mu. In binomial we have two parameters, n and p. This is the formula of the Poisson distribution is equal to 1, because the sum of the probability is equal to 1. So if you substitute all the given values, the sum of the probability will be equal to 1. Number 4, mean and variance both are equal, represented by mu. In binomial, mean is greater than variance. Number 5 is the most important, because we will also use the binomial instead of binomial Poisson distribution in the case of binomial when these conditions satisfy. For example, Poisson distribution is a limiting case of the binomial distribution when n tends to infinity, means very large, that is n more than 20. P tends to 0, means p less than equal to 0.05. So in the case of binomial distribution, when n sample size is more than 20, we cannot apply the binomial distribution. Then we apply Poisson distribution if p less than equal to 0.05. If p more than 0.05, then we use normal distribution. This is next distribution. And number 3, mu is equal to np. Mu is the mean of the Poisson distribution. You know that the mean of the binomial is the n into p. So with the help of binomial distribution, parameter of the binomial distribution n into p, you can find the mu for Poisson distribution. Because for Poisson distribution we required mu remains constant. Remains constant means if you multiply number of times with probability, it will be approximately remains constant, or you can say independent, not depend on the number of sample size and probabilities. So now you will solve the question with the help of the formula. This is the question of your book, Introduction to Statistics by Walpole, 3rd edition, page number 180, question number 7. On the average mean, certain intersection result in 3 traffic accident per month. This word is most important. 3 accident discrete per month in continuous interval. Average mu, mu is the 3, here mu is the 3. We required only mu for Poisson distribution. What is the probability that in any given month time interval at this intersection, this intersection means the average of this intersection is 3 traffic accident per month. Intersection should be same, time should be also same. Okay, you cannot use the average value of different intersection for different area or different time. Suppose you collect the data from 6 a.m. to 8 a.m. in up to 1 month. So you will use same average value for the same time, 6 to 8 a.m. You cannot use this for the 12 noon to 3 p.m. So area, time should be same, intersections should be same. Okay, and same as, suppose if you collect the number of typing mistake per page of a particular typist, so size of the page should be same and typing should be same for the probability of the next page. Okay, this is the most important thing. So find the probability that in any given month at this intersection, first part exactly 5 accident will occur, less than 3 at least 2 accident will occur. The statement of the condition will be same as the binomial distribution you have done. So exactly 5 accident means property of x is equal to 5. And this is the formula of the Poisson distribution. We will use Poisson because discrete observations occur in interval, continuous interval, then we use Poisson distribution. Okay, so mu is the 3, x is the 5, we have only one value. You can eliminate, remove the summation sign, substitute the value of mu here, value of mu 3, value of x is 5, divided by 5 factorial. Calculate this by calculator, given in your calculator. First press E and then press -3, then equal sign, you will obtain this value, 3 power 5, this 5 factorial equal to this is equal to 0.1008. So probability of exactly 5 accident will occur is 0.1008. Second part, less than 3 accident will occur. Less than 3 means maybe 0 accident, maybe 1, maybe 2, because it's a discrete variable. Less than 3 means up to 2. So we substitute 1 by 1. Less than 3, property of x less than 3 will be from 0 to 2. This is the formula. Mu is the fixed 3. Substitute the value of x 1 by 1 here, 0 first time, 0 and divide by 0 factorial plus sign, summation sign mean plus sign, then substitute the value of x 1 divided by 1 factorial, then substitute the value of x2 divided by 2 factorial. Simplify this. In this term e power minus 3 is common, you can take e power minus 3 for simplification, or you can calculate direct. So 3 power 0 1 upon 0 factorial 1 is the 1, 3 power 1 upon 1 3, and this 3 power 2 9 upon 2. Simplify this, you will obtain 0.4232. So the property of less than 3 accident will occur is 0.4232. Third part, at least 2 accidents will occur. At least means minimum 2, but maybe more than 2, not less than 2. So you have done this type of condition in binomial distribution greater than equal to 2. For greater than, if you subtract from 1, because the total probability is always equal to 1. And the range of the Poisson distribution is from 0 to infinity. So this is very lengthy and typical and time consuming. Substitute the value of 2, then 3, 4, 5, 6, 7, 8 and so on up to infinite. So if you subtract from total probability the value of 0 to 1, you will obtain from 2 to above. So 1 minus 0, first time substitute here 0 in same formula, and then substitute 1 here, 1 here, and then simplify. You have already calculated this total will equal to 1. You can write direct here this value 3, and simplify this term plus this term, e power minus 3 is common here, and then multiply by this, then subtract from 1, you will obtain the answer 0.8008. So these are the answer of the 3 parts. Now we will solve using the Poisson property distribution table, same as the binomial property distribution table, because for saving the time you have to use tables. Okay, the result will be same, but how we find the values? So with the help of this example you can understand, but all the values are given in your book in Poisson property distribution table, page number 477 to 479. So there are 3 pages. In each page you have two tables, but we select first mu. So mu is given in your book from 0.1, 0.2, 0.3, 0.4, 0.5 and so on up to 5, 6, 7, 8, so on up to 15 or 16 or 17. But in this data, the value of mu is 3. We will select mu is equal to 3, this column. This table is same as the binomial property distribution. Means in this table the cumulative probabilities are given. You can observe from the last values, all the values are 1, 1, 1, 1. So we will select this column according to the data and condition value of x from this column, and the procedure will be same as the binomial. Why? Because this value of x is equal to 0 indicate the property of x is equal to 0. If you take this value of x is equal to 1, this is the probability of from 0 to 1, not only 1. For exact one we will subtract previous value. Okay, for less than 3 we will take direct a value of 2. Exactly 5 we will subtract from the 0 to 5 the value of 0 to 4, same as the binomial property distribution. I have already explained all these 7 conditions. So now we will solve using Poisson property distribution table, and this table with mu is equal to 3 is given on page number 477. This is the page number 477. First condition, property of x is equal to 5. Procedure is same. Instead of binomial distribution we will write here notation of the Poisson distribution. P for Poisson, x variable mu is 3. For exactly 5 we subtract from the value of 0 to 5 minus 0 to 4. Same procedure, same as the binomial distribution. So first understand the video of the binomial distribution and then you can understand this. So value of 0 to 5 is 0 to 5 means this value 0.9161. Mu is 3. This value of 5 represents the 0 to 5 minus previous value 0.8153. So 0.9161 minus 0.8153, you will obtain same result. You will find using the formula. And less than 3 means from 0 to 2, right? Direct value without any calculation, without any difficulty, find from table, without consuming the time. Okay, so from 0 to 2 means write the value of 2 direct. The value of 2 is 0.4232. 0.4232. And greater than equal to 2, we subtract from 1. Value of 0 to 1 means write the value of 1. Value of 1 represent the from 0 to 1. Value of 1 is 0.1991. 0.1991. Subtract from 1, you will obtain same answer. Okay, so result will be same either if you calculate using the formula or table, but for saving the time you have to calculate or find the probability of the all distribution, binomial, Poisson, normal, with the help of table. Okay, now the last property of the Poisson distribution is Poisson distribution is the limiting case of binomial distribution when n more than 20, p less than 0.05. So next topic or next question is related to this property. This question number 12 is given on page number 181 in your book, and you have solved this question under the heading of the binomial property distribution with different values of p and n. The property that a person dies, you know that the patient or person may be die or survive from a certain respiratory infection is 0.002. P is very small, less than 0.05. Find the probability that fewer than means less than 5. Of the next 2000, n is very large, 2000. So infected will die. Find the probability of fewer than 5 of the next 2000, so infected will die. The person maybe dies or survive. You have two possible outcomes. P is here 0.002, n is 2000. If n is more than 20, P less than 0.05, then we apply the Poisson distribution instead of binomial property distribution. This is the question of the binomial property distribution. If you change the value, suppose this value is 0.2 and this value is 20, then we will solve this question using the binomial property distribution, not Poisson. Okay, this is the most important thing. So P very small, n very large. Condition is find the property of fewer than 5, and for Poisson distribution we required mu, and this if you multiply n by p you will obtain the mu, because mu is the mean of the Poisson, n into p is the mean of the binomial distribution. And 2000 multiplied by 0.002 you will obtain 4, so mu is the 4. The condition is less than 5. Less than 5 means from 0 to 4. Find the probability from 0 to 4. And mu is the 4. So how we will find from table? This mu is the 4 and less than 5. Less than 5 means 4. 0.6288, write direct value 0.6288. Okay. So now for homework, solve the question number 8 and 9, page number 180, and question number 13, page number 181. Next time we will start normal probability distribution. Allah Hafiz.